How's it going, everybody? Last day, last hours, chatbots. It's going to get real pretty fast here. No, this is a very introductory look at what it takes to build chatbots, some of the technology that exists out there currently to make it as easy as possible, how you can do this in Python by yourself, and then my attempt at doing this to help automate part of my job. A quick outline, we'll do some background on me, my motivation, types of bots, these bot development kits that have increased in popularity in the last 6 to 9 months, kind of a build your own bot framework with a little toy example of an airline bot, and then finally Malbot, my Frankenstein monster chatbot that I built to answer questions about malware. The reason why I built one about malware is because that's what I do on a day-to-day basis. I'm a data scientist at Endgame. It's a local company in Arlington focused on information security and hunting out adversaries across your network. My particular project is malware classification. Very, very simple in theory concept of just supervised learning, good, bad, when a piece of software comes in. We pull apart some features about the structure of the binary, strings, entropy, encryption, and then produce a goodness or badness score associated with. And then the other thing that I'm currently focused on is providing contextual understanding. Once you get that score back for a piece of software on why is it good or bad, that doesn't really help anybody other than saying like, oh, well, this is bad software, not why is it bad. So I take kind of these really binary level features or byte level features and then switch that into a natural language statement. This malware was classified as bad because it encrypts all your files. That's pretty bad. Some things I like, one is being a dad, which is really new. And that's the reason for the bags under my eyes right now. Sleep training is not very fun at all. Playing, watching soccer, huge Liverpool fan. If anybody out here roots for Chelsea, we're no longer friends. And then finally, traveling. At the end of the month, I go to Vienna for a AI conference where I have a paper that got accepted to CCS on adversarial machine learning. This is much simpler to talk about, which is why I'm very excited to do it. Some motivation. Part of my background and responsibility day to day is not only understanding the malware that comes in and out of these models, but also when the model is produced, why is it producing mistakes? Good, bad, false positives, false negatives. It happens. It's really embarrassing. The engineers give us a hard time about it, but it is a pretty tough problem to tackle. So what I do is I take those samples, and all I have is the binary and then its file name. File name in this case is just the SHA-256, which is a unique representation of a file. What I do then is I run a series of queries against knowledge bases that we have at our disposal. I look up things on VirusTotal, which is a Google-run platform that provides a bunch of information. And then after 5 or 10 questions that I kind of work through, I have a good idea of, well, this was a false positive because of X, and this was a false negative because of Y. After a while, 20 or 30 times doing this, I'm like, my God, I cannot do this for the next 9 months as we continue to roll out production models. So let's try to automate it. Automated it. It was working great, but it was still a lot of data to get through. Each sample was producing a couple pages of text, and lo and behold, Twitter kind of just provided the answer with all these rise of chatbot posts. There were posts every day on VentureBeat, 3 or 4 times a day on TechCrunch, CNN. The Washington Post had an article about why you should care about chatbots, and I'm like, I guess I should probably care about chatbots. It's the moral of the story. So I decided I was going to build one, and had grand visions of building like Jarvis 2.0 from Iron Man. But in the back of my mind was, oh God, I'm going to create Clippy 2.0 and everybody will hate me. So setting those expectations became paramount moving forward. So the first thing I did was try to identify what are chatbots or bots at their core. They're just automated assistants that mimic human understanding by accepting an input, producing an action from that input, and then providing a natural language response. Hence the title, Illusion of Intelligence, because there's very, very little intelligence actually baked into these. So, other than blog hits, what are some other reasons why this bot revolution is actually occurring? This part, for me personally, was by far the most fascinating to understand just from the tech field, just how fast things are moving. So 9 months ago, 12 months ago, being an app developer was like the coolest job ever, because you heard people like 14-year-old kids making a game and then becoming like millionaires. And then I was just trying to figure out why malware was bad. Seemed like a very terrible life decision on my part. But then what happened was Google Play and the Apple App Store, they kind of suck from a UI standpoint. And when you go there, you see the same 20 apps day in and day out. So all these other app developers that were working feverishly to create awesome products were getting buried. And the only way you could find them is if you were alive and using the internet in the 90s and knew how to work like Yahoo's category. Because you just have to go category, subcategory, subcategory, and then be like, oh, well, there's the United Airlines app. That's exactly where I expected it to be. And on top of that, there was this whole advent of Messenger, Kik, Telegram, and all these messaging platforms. I'm in my 30s. I don't use messaging platforms a whole lot. But for some reason, my mom and my dad and all of my extended family tend to use it, as well as teens. So the app developers were like, well, everybody's hanging out in these messenger platforms now. Why don't we try to push our data there, create very basic bots to get our information out? And when I say basic, I mean absolutely basic. CNN has a chatbot, if you could call it that just says, hey, CNN, give me the news, and then they send you the news. It is like the most basic thing that you can do. But if you're spending all your time on this app and you don't want to switch, you don't want to jump on the CNN app or open up Safari and then type in CNN.com, this is fine. And you get gists. They don't provide the full article. You can narrow it down. It starts to learn your behavior. For me, it was a lot of political stuff until I got really sick of the political stuff, and then it shifted over to just sports, and my life became way easier. But yeah, super easy. The other big thing is just sometimes chatting or conversing is easier. This, if anybody orders pizza a lot, can probably guess the company here, but this is a click-through UI on a website versus just PizzaBot, the hypothetical or all-time great PizzaBot. Here you have in the click-through delivery, pickup, size, sauce amount, toppings amount, billing information, credit card information, username, password, all of this stuff. But if I go into Messenger, where my identity is stored and my billing information, credit card stored, I can be like, yo, PizzaBot, it's pizza time, cheese, medium, the usual place, and then it's done. Like 5 seconds, a couple of text messages, and you've completely eliminated the need for this clunky UI. I apologize to anybody who builds UIs, but sometimes they're just not ideal. So you get in situations like this where it becomes like, oh, well, this is pretty obvious why this would work out. We ordered pizza like this before using a telephone. I don't know who does that anymore, but if you do, that's awesome. So we'll dig a little bit more into the types of bots, just to give you some background as we move into the bot development kits. The first up is generative versus retrieval. These are like the two highest levels of bots. Generative is kind of the dream, which is everything stochastic. It receives an input and generates a completely novel output. You can think of Ex Machina or Her is the examples of something like this. Not a lot of real world ones yet. And then retrieval based is something that I would just say is more doable. It's rule based. Even if it uses machine learning, it's still super straightforward. It takes an input, creates a feature vector, classifies it, and then produces an output based off of some sort of label API mechanism. Open domain, closed domain is way too obvious for the amount of bullet points that I have there, but open domain means you can talk to this bot about anything. Siri, Alexa. Closed domain is something much more limited in scope. You reduce the amount of inputs and outputs that you can take. Everybody in here would probably, if they ever wanted to build a bot, for their company would be in the closed domain circuit, because there would be very specific vocabulary or domain knowledge you would pass to that bot. Actually, there's a guy in here, Anthony, right there, who would probably build a closed domain bot because he works for city government, and regulation or regulatory data is all highly structured but very vocabulary specific. So you would just focus on that. It's a much easier problem to solve. Finally, long versus short conversation. Long conversation requires some semblance of intelligence in the fact that the bot kind of has to keep track of conversation. It's keeping state. It understands what you're asking for and why, but it also in the background knows it needs to extract a series of parameters or entities, if you will, in order to complete its job. A good example would be troubleshooting or reservation booking. If I want to make a reservation for something, I can't just say, I need to make a reservation. I need to provide way more data. And the bot, knowing that, if you don't provide it right away, will steer the conversation until it grabs all that. Short conversation is much easier. It's Siri. It's any sort of QA bot. What's the weather in San Diego? It's significantly better than Washington, DC. Something like that. And then this is not really a type of bot, but more of just an example, good versus bad bots. Yeah, this is good, because I'm like, well, do I have to explain Taybot to anybody? No, I hit this. I think, please come back. All right. This is fine. It's just penance for about to talk crap about Microsoft, I'm sure. Okay, water this hand, will not put it down the rest of the time. Channel my Marco Rubio here. So good bots, yeah. All right. Good bots, do not pay. Has anybody heard about the do not pay bot? It's kind of a really cool idea where if you live in Seattle, London, or New York and you get a parking ticket, this bot, who was created by like an 18-year-old kid at Stanford, will walk you through parking ticket law, which is probably a huge area of interest for some lawyer. We'll walk you through and then say, like, here's what you need to do to fight this. And it's been wildly successful. It's like fought and won 200,000 cases already in like 18 months. Esther-bot, which is another really, really cool idea. This woman, Esther, created a bot of her LinkedIn profile so she wouldn't have to talk to recruiters anymore, which is brilliant. So she sits it on LinkedIn, and then the recruiter talks to this bot, thinking that it's her, about her background, what she wants to do, salary requirements, whatever. And then if she gets interested, then she drags herself into the conversation. And then the infamous bad bot, Taybot. I wanted to have some screenshots, but they were all so inappropriate that I felt guilty even putting them on there. Great idea, like, let's put a bot out there and let the world educate it. But the world as it exists on the internet is pretty terrible. So this went from being a great idea to a bad idea in the span of like 2 hours, and was so corrupted and polluted and said some of the most inappropriate stuff probably ever uttered outside of 4chan. So that got shut down very, very quickly. But it was an interesting exercise in how you can take online learning and manipulate it for whatever end you want. So out of these, which is the best? Generative would obviously be the best if we could get to that point. Just not possible right now. From a data set standpoint, even from a training standpoint, it would take, sometimes it takes months to generate like a movie quote bot. Retrieval, very simple, small data sets, closed domain. There's no grammar mistakes unless you're not very good at grammar. It works best in closed domain situations. So this is what we'll ultimately focus on because of bot development kits. There's been an influx of companies. They all have super trendy .ai domain names, which I'm constantly envious of. Chatfuel, Wit, API AI, they provide a simple user interface to build closed domain, short conversation, goal-oriented bots. That's their bread and butter. They've gotten so popular that they've been purchased by some of the big boys. Facebook bought Wit last year. by pure happenstance, Google bought API AI like 2 weeks ago when I was making this slide. And then Microsoft, Amazon are creating their own bot development kits because they have platforms to service them. So they want to try to get developers in there the same way the App Store and Google Play did 5, 6 years ago. And the architecture to these things is extremely simplistic. It's a hybrid of rule-based and machine learning. It depends on the amount of data that you have at your disposal to train on. But all the ML and NLP related work is completely behind the scenes. Like the user has no idea. They're just pointing, clicking, throwing some data up, and then they hit a train button, and then their bot just starts working. So it's super nice for people who work in like the social media managers and things like that within companies. You don't need to hire a software developer to build these things. The framework that you are responsible for providing is something like this on the right, which is just a flow diagram decision tree. In this case, it's like 1-800-Flowers, I think, where each question you just move along in kind of a choose your own adventure. You have a task or an action that you're trying to carry out, and that's just buy some flowers. So how do you go from hello to you just bought flowers? That's all you have to think about. And the way you do this is by following this sort of workflow. The bot development kits more or less help you with session, which is just when the user starts interacting with the bot, it locks you into a session, logs everything, everything's associated to one user. Identity we touched upon, which is just capturing your persona and making it accessible to the bot. Billing information, credit card information, whatever. And then the dialogue script is really the beginning point of where you're interacting and providing context to the bot. Context and intent are really the two, I guess, core buzzwords that you'll hear a lot of times with bot development kits or just building chatbots in general. Context, all that's doing is that's your little manager. He's there just watching the conversation, understanding what all needs to happen, and ensuring that you are hitting every step of the way in order for the bot to carry out the task. Intent, all that's doing is taking a user input, and then the intent is just the label that the little text-based classifier comes up with to move you down the line. And within those intents, there are sometimes entities. Entities from anybody who understands or knows NLP. Are just parameters. They're usually proper nouns, city, states, pizza toppings, anything like that. All you're doing is you're providing a list of these entities that's like, well, once you identify what the user wants, now we have to figure out what exactly they're trying to get out of it. So in the flower example, the entities are types of flowers. You can create permutations just so you can handle some diversity in language. I think this is Wit AI. They got kind of lazy by just making it plural as your options of growing your data set. But you can do other things too that we'll get into a little bit later. Training data is kind of the biggest one that presumably would scare people off. Certainly put me off a little bit as well. How do you build something that can be robust enough to handle a regular human being entering in a string of text and then understanding it when you have like 5 examples of what that person could potentially say? What the bot development kit community does is they have predefined domains and knowledge packages. So believe it or not, that pizza bot example was one of like 300 pizza bots. So when you have 300 pizza bots and 300,000 users talking to a pizza bot every day, your data set starts to grow quite a bit. And that data set isn't just tied to Domino's or Papa John's or Little Caesars. It can be used by anybody. So these companies collect all of that data and they kind of anonymize it, and then they make it available to the next person creating their bot saying, hey, you have like 5 good examples, how would you like 300,000? And the answer to that should always be yes, please. Let's make that happen. Additionally, they'll provide common intentions or entities. So PizzaBot, they're going to give you all your toppings, so you don't have to type that out, but give you the option to add in as you see fit. So, natural language processing, machine learning. As I said earlier, it's kind of baked into these platforms, very much behind the scenes, but that isn't to say that they don't do it and don't do it really, really well. The folks with AI and API AI, we're really good at this for a reason, and they're even more of a reason why Facebook and Google bought them. So if you want to think about it in the context of a conversation, the input hits the NLP pipeline to create the features that are fed into the machine learning algorithm that classifies the intent that produces the output. When you think about it like that, all of this stuff, tokenization, synonym generation, all of that becomes way easier to understand. And you start to see, like, just because they have AI in their domain doesn't mean they're doing some sort of weird, creating a fake brain or anything like that. It's all very standard. There's been a ton of talks, even at PyData, on this. Anybody could apply this. But it's all very, very easy to use. And like I said, it's literally a button that says train, and you have no idea what it's doing, but it does it well. And additionally, another thing that I personally like is they use models that can be updated on the fly. So SVMs or naive Bayes, they do logging. So each time your user interacts with your bot and you provide an answer, you kind of self-participate in active learning. So if you gave a wrong label, you correct that label, and then that gets fed back into the model, so the next time you get it right. And there's something to be said about that customer service aspect. So, how do you do this in Python? There are a ton of ways to do this in Python. From NLP standpoint, you have some great options. SpaCy, TextBlob, parse date time, NLTK. From a machine learning, deep learning standpoint, Keras, scikit, TensorFlow, all of these can kind of be mashed together in a Frankenstein sort of fashion to create your own chatbot. And as an example, we're going to create an airfare bot at a very high level, just to give you an idea of the workflow that I presented a few slides ago. So the airfare bot is going to be very, very basic. It does two things. It will either show you flights or book a flight for you. So once you know that those are your actions, what do you need in order to successfully do those things? Well, when I'm on Kayak and I want to see flights, I just need to provide a kind of a to and from, maybe a date. And then I get results back. And then from a book a flight, I need to provide a to from, but in reality, it's really a flight number to, flight number from, and then a date. And those are the actions, those are the parameters, those are the functions that feed the API that will produce the results that your chatbot will spit out. So to get those parameters, you'll do entity extraction to extract from text cities, airport codes, dates, times. From intents, you're going to have to create a series of them, like show me flights from A to B. Are there flights from A to B? Can you book flight 1, 2, 3, 4, and 5, 6, 7, 8? A bunch of those. And then finally the context, kind of the playbook for the bot. You have a show flight playbook and a book flight playbook. That's all that's going to do is once you enter one context, it's going to head down that path full speed ahead until it accomplishes its goal. So quick NLP 101. I don't know, maybe it should just be 001. This is very basic, but we're going to use SpaCy. If you guys are familiar with SpaCy, it's really, really great, super intuitive, not very difficult at all. And our sentence here, which mimics what a user would potentially type into a bot, show flights from Washington to Denver on Monday. We'll break that down, we'll tokenize it, and then grab its parts of speech, tokens on the left, parts of speech on the right. And the reason why you can do this is maybe you don't want to use machine learning at all. You could literally just build a giant decision tree, if-else statements, and parts of speech will help you with that. Because things like show or order have verb and noun meanings, you can go through and be like, well, I don't want to go to a show, or I don't want to start a task order. Like, I want to be able to order a flight or book a flight. So I'm going to look in that sentence, if show is a verb and flight is a noun, which flight should by and large always be a noun, then we call or set the context to show flights. Then you move them down the path. Very, very straightforward, and goes from zero understanding to some very basic natural language understanding in 3 lines. WordNet is the way you can go from those 5 pieces of training data to 25, 35, 100. In this case, I just take the TextBlog library and feed in the WordNet platform. I think Mighty, OpenNLP, and NLTK all have access to this as well. I take book, and then I produce the synsets associated to book. Synsets, synonyms, whatever, very, very straightforward. We see that book is represented as a noun, way more than I thought was possible. And then we get to the part that we're interested in, which is reserve verb number 4, arrange for or reserve something. So that looks to be closest to what we mean for book flight. So we can take that, throw it up on the right-hand side and say, give me its base form, its lemma, and then once we have the lemma, let's go through and look at the hyper and hyponyms, kind of the micro and macro variants of this word. We'll put them all together into a giant list, and then we'll create a set, and we'll get potentially new data. And we do. We go from the word book to now we have reserve, hold, request. Probably not going to use bespeak, but maybe if we have like an old-timey gentleman who wants to interact with our chatbot. Keep open, save. Quest would be another one. I might start doing that when I'm at the airport, quest a flight. But some of this is obviously going to require some hand annotation. But if you're thinking about things and you're like, all right, I know I need to accept book flight, but people are inevitably going to ask other things, this is like a super quick hack to go from 0 to some alternatives. That's all it really is. Once you have your entities, then you can kind of move on to intent classification. As I said earlier, we could keep this very straightforward with just regex and a series of if-else statements and make it the most basic chatbot ever, but it'll crap out after your first user because nobody uses it the way you would use it. That's what I have found out. And it gets annoying very, very quickly to explain that to people. But machine learning kind of allows you to be fuzzier, handle misspellings, using things like n-grams versus or a bag of words, and treating your intention labels as a multi-class classification problem. Use an SVM, naive Bayes, something that can update each time you get a new data point and a label. And we can take our very toy data set here of types of utterances that could come from a user and then the context that that would likely mean. We pass that into scikit's TF-IDF vectorizer, and we break it down between 2 and 3 n-grams, transform that into our feature vector to then train on a linear SVM. And then we have our statement that we've been using throughout, show flights from Washington to Denver on Monday. We classify it. We get the label show flight, and now we know, okay, show flight requires some entities to be extracted. Show flight requires a to, from, and a date. This is where named entity resolution comes in handy. There's definitely been a talk on this already, so I'm just going to glide over it. Named entity just breaks sentences down into noun chunks and then tries to derive whether or not any of the points within those chunks are proper nouns, companies, dates, locations, names, anything like that. So we'll use polyglot. I don't know if people know this. I found it the other day, and it was way easier than OpenNLP, but I would never tweet that because OpenNLP is very active on Twitter. But yeah, very straightforward, 3 lines, and I go from like having no natural language understanding about a sentence to grabbing the things that I need. That's awesome. But I still have some trouble with the word Monday. Parse datetime is an alternative to named entity resolution, but specifically for dates and times. It's a very clever name. You do the same thing. You basically pass that blob, you parse it, and then you're able to extract things like month, date, hour, whatever. So they're able to interpret Monday and then give back to me, oh, well, based off of the day that he asked that, Monday for me, or my understanding, is October 10th, 2016. So at that point, I have everything that I need. I can go out, reach out into the database, pull down flights, and present that back to the user. And then that is AirfareBot. Feel free to create that at your earliest convenience. So the last area is Malbot. Malbot, as I said, was just really kind of a hacky way for me to get out of doing some of the day-to-day grind involved with analyzing malware, some of the reasons why something may go awry on the model. It's retrieval-based. It's even easier than the airfare bot in the sense that it's just strictly QA. There's nothing really more advanced to it than that. I had it mapped to like 9 or 10 intents. Those 9 of them involve the questions that I normally ask a piece of software when trying to figure out what went wrong. And then 1 intent was just to handle unknown things. So if anybody else used it, it would be able to redirect them down to, hey, you messed up. You can't ask me, like, why are we alive? I'm going to steer you. Why don't you ask about section entropy? That's way cooler and something that I can answer. So the questions I generated were the same way that I generated them for the airfare bot. I had 5 or 10 examples for each one, and then I started using lemmas and hyponyms, and grew that set out to a more respectable, like, 100 lines. And then with the addition of logging, adding logging in, I was able to grab from my colleagues how they were questioning things. And that more or less replicated my beginning and end to analyzing false positives and false negatives. And it was great. I built it using a way too complicated Keras model because I thought I was being super clever. And then I realized that I actually got way better performance with just a linear SVM. But I felt obligated to leave Keras in there because it was in my description for this talk. So, delivering on promises. Never say I didn't do that. So what are we looking at from an architecture standpoint? We kind of saw some examples on how to do this in Python, but how does this all actually scale out? The easiest way to describe this is we start with the user utterance or user input, and then what I'm constantly doing, or what Malbot's constantly doing, is it needs to know what it's talking about. Because you can't just jump in and start talking about malware because he has no context. So the first thing he does is each time you enter in a statement, he is looking for a SHA-256. That is my one entity that I'm looking for, which is lucky because creating regex to find SHA-256 is super straightforward. If he finds a SHA-256, he then loads everything from our malware knowledge base on that sample into memory, and then you can begin querying him or interrogating him or however you want to capture him. So once that's ready, a statement comes back out. It says something like, my persona has been uploaded, please ask me questions. And then the user knows, okay, I can start asking questions about this sample. So at that point, each question that comes in gets tokenized and broken down into features, classified, an intent label is created. That label maps to an API that maps directly to the malware knowledge base. And then I did this kind of hacky Mad Libs sort of thing that you see down there, where the intent label is like entropy API. So when entropy API hits, I can query directly with entropy API into the malware knowledge base, grab that data out, and then do a print format or a string replace for entropy API with the actual data. So then it says, I have high entropy. So there's the illusion of intelligence. Keep going back to the title, because that would be the clever thing to do. Additionally, I mean, it's the same thing with name, sections, imports, exports, all of that. It made it very, very easy to upload new intents, to handle any sort of conflict management between like misunderstandings of user inputs. Adding a logging module became important because, like I said, I wanted to continue to grow that data set and understand why my users or other teammates were querying this piece of software the way they were. And I made it all available on an internal HipChat server because that's where we have access to the bulk of our data. So architecture considerations, I've more or less touched on a lot of these. Context management is by far the most important thing because that just allows the user and the bot itself to be on the same playing field and know what they're talking about. I added short-term memory because I work for a cybersecurity company and they like to break everything. Even harmless entities like malware bot came under duress almost immediately. So I created short-term memory to basically say, if you're going to keep asking the same question, I'm going to direct you to something else. So he has like a little stack that he has where he remembers what he has said previously and what the user has said previously. And if it hits on any of those, then he calls you out. And then we do some hip chat shaming, which is clever. But I don't know. HR might not like it. But and then logging was the other core component that was very easy to implement just using the Python standard logging library. So this is what he looks like. It's not great, but this was the only way I could get it out of our network. But you can see there, yeah, Malbot escaping into the wild. You start out, everything is a slash command. If you guys have HipChat or Slack or anything like that, it's pretty standard fare on how you interact with the bot in these messaging platforms. Slash Malbot, SHA-256, he comes back saying, I've processed this, I'm good to go, start asking questions. What is your name? He provides a list of names that he has been called according to VirusTotal. I can distill down when were you compiled, what functions do you import, do you have high entropy? And then all of a sudden, I want to switch to a new sample, I pass a new SHA, he immediately forgets what he was talking about, switches over, and you start the conversation again. This got a little bit more complicated when more people get involved, because then you're saving context and state for multiple users. The easiest way to do that, at least in HipChat, which is kind of a nested dictionary, that took about 30 minutes to implement, but wasn't too bad, all things considered. But yeah, so Malbot, right there, in all of its glory. So some things left that I want to do, just to make it a little bit more robust and practice what I preach on some of these other slides, is start to handle yes and no questions, because yes and no questions are surprisingly difficult. If you guys have looked at the Facebook Babby data set, it's very, very cool. But they talk about the same thing. It's, would you like to see more functions? And then the user says yes, and then you have to remember that you just asked it, would you like to look at more functions? Yes. Seems totally easy until you're programming it, and then it is a complete nightmare. Likewise with entity extraction, because I don't work in a domain that has like pizza toppings, which would be really nice, or like city codes. I have things like kernel 32 DLL. Can I build an entity extractor custom for my domain? And this is something that I think a lot of people are probably in here would have to deal with too. Anthony with like government regulation data, medical data, legal data, there aren't entity extractors really for that. So how do you create your own so you can allow more targeted queries to occur? Show me imported functions from kernel 32. That's a much harder problem to solve, but probably a much more fun problem to solve. And then finally, what do you do when your user is just incapable of hitting any question that your bot actually knows how to answer? Which was amazing to see. We launched our bot, and then within like 2 hours, I just had people coming up and being like, why can't I ask it this? Why can't I ask this? And I'm like, well, you know, it's a project that I was doing for PyData. It wasn't supposed to be anything other than that. And I don't know why I uploaded it and let all of you use it. This was just a terrible, terrible idea. So the next thing is like, oh, when you ask a question and I don't know, I'm going to steer you into saying like, hey, I actually don't know this, but why don't you ask me one of these? I feel like it could turn into like Kramer with Movie Phone, if you guys remember that Seinfeld. Why don't you just tell me what you want to ask? But we'll get there. We'll get there. But anyway, yeah, so that is Malbot. I put together a little list of resources to kind of get you going, both from the bot development kit side and just general bot resources. Brand new field, even though they've been around since the 70s. It's a new field, and it's very fun to work on, and there's potential there to help automate your day-to-day job. Questions?
Can you open the pod bay doors?
Yes. Always refuse. What's that? Yeah, I'll push them SlideShare or something, definitely. Cool. All right. Thanks, guys.
Thank you.